Hello, hello. As you see, I am Googling more blueprints for the Sierra because some decisions have been made. I'm just gonna wait for a few more people to arrive on the channel and then we're gonna talk about them. As you can see, I have made the Audi. Isn't it pretty? Ah, love this model. If you can get it, I mean, out of the all of the speed champions, I think this is the best by far. Really love it. Uh, Today we are not gonna build a specific car. Today we are doing a few things. First, I want to find blueprints for a Sierra, uh, but not the Sierra that we are building now. So you see, let me explain. Let me put the Audi on the side and let me explain it on the Sierra. Okay, so the big problem here, the big problem here is of course this area here. So I have decided that I do not want to deal with the rear door, and the B pillar really is, I mean, in this setup it's a little bit problematic. So um, we're gonna build a Cosworth version, not the Sapphire Cosworth, but a normal Cosworth. So basically, the picture that I imagined is this. So you know, so we're gonna build the hatchback version. So we don't have the door. Uh, we can make the B pillar better. We're gonna have the hatch. So at the same time, the push rods are gonna be different. We're gonna make them so that we have trunk space here, and the seats can be folded to the front. So the springs are not gonna be um, basically horizontal, but they're gonna be vertical with just a pivot here. Yeah, I guess the RS 500. Yeah, so we're gonna build the RS 500 Sierra instead. You know, so nothing drastically is changing. Just we're building a slightly different car. It's gonna make our life much easier. Uh, e- I mean, the rear the rear fender is also gonna be much easier because with the with these here, this is, I don't know, not gonna look good like this. And if we add like the Ferrari fender extensions and make the car, let's say, red, for example, then it could work out. Maybe, I don't know. So that's the plan. So nothing that we did here has been in vain. So except from this part on, we're gonna change a few things. This angle will be bigger, of course, um, but I have to measure them. Maybe, if we're lucky, it's the same as in the front. I don't know. Maybe it is. If it is, great. We already know how to do it. Yeah, and it'll make everything here in the rear easier, more transparent, and we're gonna have a hatch. Um, it'll be great. You know? Um, so I think that's the correct path to go. So and of course, at the same time, the front of the car is also going to be the same as the Cosworth one, which makes it a little bit simpler. Yeah. So that's the general plan, and it'll look better. To be honest, it'll look better because we can make uh, muscular rocker panels. That that makes everything a little bit beefier. Um, it'll be grand. It'll be grand. At the same time, I don't know. We are gonna redesign the suspension slightly to fit the bodywork. I don't know. Maybe not. Maybe we'll just leave these wheels on. Um, so that's one of the parts. One decision that has been made. The second decision is something that I want some feedback. So I was talking to various people, and we it was suggested that it would probably be better if we move to Twitch. So uh, all of this, the channel and stuff will remain the same, but it's not gonna be on YouTube, but on Twitch. I will make a poll about this on Facebook, and probably should make a poll somewhere more visible. I don't know. Maybe on Eurobricks, to see if if you would be interested in us going over to Twitch, because I think that the channel would have a better potential for growth. I initially started to stream here on YouTube just simply because well, I had an audience. There was nobody on Twitch, so you know now that you know that the streams are there, I think it should be relatively easy to switch over to Twitch. That even rhymed. Um, we would have more tools there, I think, because YouTube really is it's really limited. So that's the second thing. Now the third thing involves our projects here. So the the Sierra is going to be a Cosworth, that's decided, but it's the other projects that we're going to do. So I was talking about with Zero Bricks from the Buwiz group um, about some challenges this year. So obviously we're gonna do the Chiron, which is gonna be supercar build that we're gonna go completely overboard as much as we can. But the second challenge is there's gonna be a meet in September where there will be various categories of cars they're gonna be racing against each other. And one of the categories is 1 to 10 supercar category. So for the purpose of that, we're gonna design our race car. So it's not gonna be just a Chiron. It's gonna be designing a 1 to 10 race car. I don't know what the rules are yet. You know, Zero Bricks needs to. Okay, that went well. Zero Bricks needs to update the rules to so that we know what what the weight limitations are, what wheel size we need to use, what the size dimensions are, how many motors we can use, all that stuff. So that's going to happen as well. So we're going to, of course, live stream all of this. And these are the two most crucial projects. I mean, besides the Sierra, these are the two most crucial projects for the year. So supercar, probably Formula One style body, Formula One style chassis with just bodywork on it, and then the Chiron. A red piece. I I have just. I think I have just this. That's the only red panel that I have. I don't even know where I got it from. It looks dirty. Wow. No, no, I have another. I have another one. Of course, it's just the other side. Yeah, so I don't know. Let's put a panel in. There. As I said before, the Sierra is gonna be not a 4-door, but we're gonna make it 3-door, basically a hatchback. So the RS 500. That's gonna be the plan here. Okay, so since we would make it an RS 500, this opens another can of worms for the rear suspension. So the RS 500, so the racing version, has a slightly different rear suspension than the stock Sierra. Let me paste you a picture. Where is it? There it is. So this is the rear suspension of the Sierra RS 500 for racing. And maybe we should think about doing it this way. You know? So we would rework the suspension that we have now. It's a good suspension, but it can be done a little better and more interesting. Exactly, the Texaco Sierra. It looks great. I would not want it to be black because we have done that. We have a black car, so I would like to do it. Well, white would be my choice, but I guess if we make it red, it would be okay as well. Since I think there are enough red panels. Not sure, but I think white is probably not out of the question. Except if we make some defenders out of soft tubing and the two stud lift arms, like some people do. Then maybe we could do it all white. Yeah, I would like to make it white, maybe. Yeah, that wouldn't be so bad. So I would like to hear your thoughts about us moving to Twitch. That's the first thing. The RS version is decided. And of course, we're gonna have some supercars. So, since I have been thinking about the design of the supercar suspension and all of that, first I would like to start thinking about the design of those cars while we are, working on the Sierra simultaneously. So let me discuss a few options that are available. So since we are gonna put a lot of power to the wheels, um, we are gonna put a lot of power to the wheels, and we have a decision to make. So the option here is to use the Lego differential, of course. Let me get you closer. On your only account. I don't understand, Kevin. I don't understand. I need more context. But yeah, hello. So, since we would be putting a lot of power with the Buick motors, consider it's gonna be 8 Buick motors. That's a lot of power. And since we want to build the car as light as possible, we're gonna try to minimize the strain on the vehicle. And we have like a few options. Okay, let's say that these two are the front and rear differentials for now. Okay, let's just discuss layouts. These are the front and rear differentials. And let's say that these are Buick motors. Okay, they're black. I mean, the Lego RC motors are black, so let's symbolize black motors. Okay, so the way that a few people do it is that they basically couple the motors directly to differentials. Hey, Zero Bricks, I'm just explaining my thoughts regarding supercar drivetrains. So imagine again, these are differentials of sorts, or let's say power transfer units, front and rear, and these are two sets of 4 Buick motors. Okay, so there are several options how to set up the drivetrain. Let me. That's better. Okay. So what many people do is that they basically couple the motors directly to the wheels. So basically to the power distribution to the wheels. Now imagine these are the axles. So imagine these are the axles, and then power goes directly to the wheels. It's the most efficient system if you want, because you have, if you couple motors directly to the wheels, you have the least amount of flexing and twisting of axles and stuff. That's one of the approaches that we could take, but I don't like it. I don't like it because it's boring, and I don't like boring drivetrains. It's efficient, but it's boring. And I would like to do something that's a little bit more interesting to me, and hopefully to you. So if we discount these two, because I would like to have kind of a resemblance of a real Bugatti, we have a few other options. So one of the other options is that we have a differential on each side. Again, I'm gonna substitute. I'm gonna just put this guy in. Ah, yeah. I'm gonna put this guy in here, like there, just so we symbolize a differential. Doesn't matter which one it is. Just bear with me. Now, okay, so let's say these are our two differentials, front and rear. Now, we could have then a central differential, then the two engine blocks. So this would be 2 times 4 electric motors, so 2 times 4 buggy motors, and which would act upon the central differential, which would be then providing power to each each differential on each wheel. Now, this is very controversial because of the amount of power we are transferring. If this was a Lego model, this would be okay. The problem is that the forces involved here are overpowering the structure and the strength of Lego. So in this case, and we want a gearbox as well. That I forgot to mention this. We want a gearbox as well because we want the car to go as fast as possible. So we have a gearbox with a low gear for starting the car, and then once the car is rolling, we switch to the high gear to make it go as fast as possible. And of course, in this case, since we have so much power, we need to double everything. So every bank of motors needs their own gearbox. And then the central differential would be, well, it would be overwhelmed, basically, if both act on it. Now, I was advised to go without a differential entirely, but let's discuss a little bit further. So, this option in its in this form is bad because the central differential is gonna be overpowered. We have to think this is the best differential Lego makes. So if we don't want to make our own, so with all custom parts, we have a big problem. This is going to be a problem as a central differential and as a differential in the front or rear. So you see these gears here are the weakest point of the entire system. Oh, come on, focus. My God. Okay, so this is the weakest point of the entire system because you see how little engagement there is between the axle and the gear. David, stop spreading negative energy. Why are you so negative? It's not impossible. It's absolutely not impossible. It's just a matter of engineering. So the problem is this small gear here. Now I have solved this issue by basically doing in the Mustang, I have basically I have cut this gear in half, so I use basically half of this instead of this. So you see, if I use, oh my god, no. So you see, I use half of this, half of the black gear instead of the tan gear. Why are you not focusing? I swear, by the next stream, maybe not tomorrow, but on Wednesday, I will turn this table around. So we are gonna have a uniform white surface. You can see right away that if I cut this gear in half, I have a much better engagement, because you see here in the round part, come on, we don't need to see the gears on the table. You see in the round part here, there's no engagement and there's weak points, which we totally don't need. So one of the possible ways would be to cut this gear in half and use this gear on basically on either side of the differential. Okay, that would be so here, and then of course here in the front. This would make the differential itself a lot better. The engagement would be the same with the gears, but we could also make this gear slightly thicker so that the gears would be pressed together, and we would create basically a limited slip differential of sorts, if you know what I mean. Just by adjusting the thickness of these, we would make this basically very hard to turn. It could turn, but very hard to turn. And we would use three, not three. That's we would basically use two of them. So we would have one differential for this engine bank, and then another one for the other. So we would have two gearboxes and two differentials. Immediately we would split the power between two, and the drivetrain would not be under so much stress. Then the second thing is, of course, the engagement here in the differential itself on the wheels. Of course, we would want this to be 1-to-1, not like this, and especially not with this guy. Simply not with this guy, simply because of speed. Since we're gonna have enough power, we want this to be basically 1-to-1. Okay. Now it did, but the big turntables are useless. That differential was split apart. So the Mustang right now, just a second, because the car is full of parts. So the differential in the Mustang right now is, well, we are not gonna be able to see it because it has well, it's covered, of course. This differential, by the way, is bulletproof. It can take whatever. But I think I have another one. I just need to find it. I think it's in the other box. Yeah. And the Mustang, of course, being heavy, it's heavy and fragile compared to modern stuff made out of lift arms. Okay. Let me just see if the differential is somewhere here. I do have these. I know I made the differential. There's another differential case, of course. Maybe I used this case. And I just need to find the half. Here it is. Here it is. There it is. Okay. Yeah, sure. I can show you the Mustang. I mean, it's right now. It doesn't have an engine. The engine is on my desk. But you know, there's enough videos of it driving around. Let's focus on this here. So I actually did make a differential, and you see all of this is so tight that the gears actually stay in. Obviously this ring needs to be glued to this, but the essence here is that we can have, see, we can have a differential that is able to handle the power. And well, Zero Bricks actually suggested that a differential would be detrimental to the car. I disagree. I disagree because once you have a car that goes very fast and you don't have a differential, the speed differences on the ground can be quite large. And if you don't have a differential front and rear and on each wheel, I think the car can be very hard to control, because at 50 kilometers an hour for a 1 to 8 car, that's a lot. That's like Bugatti. That's like Chiron speeds in real life. Like, it's going. Imagine that's 50 kilometers per hour times 8. That's basically 400 kilometers per hour. That's a lot. You know. It's the scale that makes this. So it's possible, and I want the car to be controlled. I want to be able to control the car. So for this, I want the suspension and the steering to control the car, not the engines, so not the motors, because this is just gonna put more strain on everything. And by tasking the engine, so the motors and the drivetrain, to just propel the car and not steer it, we are basically putting less stress on all of the components. That's my reasoning. So I would like to make a differential like this. Basically, we would need four of them. One front and rear, and two in the center. And we would have basically the two. What would happen? We would have two banks of motors in the where the Bugatti engine is, of course, in the center of the car. Then we would have a differential. No, come on. One of the differentials would be the perspective would be just behind them. So the engines would be really tucked with the rear differential. And one of them, of course, would be in the front. However, it's not that simple. We will not have a central shaft like before, but we would have two shafts, and we would have the engines. So, or well, maybe not the engines, but the output on each would be turning in opposite directions. So basically, exactly, I would have four output shafts. I'm getting to this. Okay, I'm getting to this. So I would have four output shafts, and here comes basically the differential casing. So we have two output shafts on each side. Okay, and now we get to the, well, one of the differentials. Doesn't matter if it's front or rear, they'll be identical, just mirrored. And we would have, let's mimic this for the differential, because we would probably, it's too small, but yeah, we could make something work. Maybe we would be able to, let's see, is it big enough? Yes, it's big enough. So what we would do, we would of course hollow this out, remove this. I think I even made a differential like this. And what would happen, let's say this is the axle through it. Come on. What would happen? So obviously, if we do this, we cannot use this exact case, which is a bummer, but we can deal with that. And we would then have two input shafts. Okay, let's get rid of this. It's not going to work anyway. Two input shafts coming from the engine, of course. And these two input shafts would be connected to the differential, like this. So since we want a 1-to-1 ratio, these are the two shafts coming from the gearboxes. And they go through the car to the rear. And there's gonna be, you know, a central differential on each of them. So there's gonna be a differential here, a differential here. That's gonna be driven by the gearbox, and the gearbox is gonna be driven by the engine. So we're getting more complicated by the minute. And on let's now see take a look at just one such line, so not both. So let's say now that these are our shafts. Okay. Well, basically, let me put something together here. That will make sense. Yeah, I need more parts. So, well, basically, I don't need any of this. I just need a dummy differential. I'll take this one. One on either side, yeah. No, I don't know. I guess I could do this, but I don't know. Okay, so basically, this is just a mock-up, of course. Yeah, wait. Let's do it with these here. It's gonna make more sense. So we're gonna have a differential like that. Okay. So this is the drive line longitudinally through the car. So here's one of the engines. Then we have here a gearbox. Yeah, let's place it like this. Doesn't really matter. I mean, the lengths here are irrelevant. There's a gearbox, and then on the end of the gearbox, there's the gear driving this. And then, of course, there's another one doing exactly the same to the other axle. Now, the gearbox, of course, is going to be, smaller than this. I guess it's going to be, well, not smaller, it's going to be turned this way to use up as little space as possible. And I need to see whether the engines are going to be on the inside or the outside of those shafts, and then we have to see how to connect them here. That's my consideration. I mean, yeah, that's basically the packaging. The packaging of this is going to be important. So I don't want this to be huge. I want the engines to be, and the engines and the batteries need to be as close to the center of the car and as low as possible. So we'll see. But we're still in the design phase. I don't have any of the engines. I have no idea how big they are. I mean, I had them in my hands, but when you have one in front of you, you suddenly see, oh, it's too big or it's good enough. I don't know. And of course, in this system, there needs to be a one-way clutch. Obviously, we need a one-way clutch because without a one-way clutch, as soon as we go off the power with the engine, and the car is going like 30 or 40 or 50 kilometers per hour, you know what's going to happen with the drivetrain of the car. It's going to explode. I know Buies, the new Buies has some settings that you can adjust the resistance of the engines when braking and stuff. I don't know. I have to test this. Maybe the programming is good, but I like my mechanical safety. So even if the programming is not gonna work, this is. And of course, the other problem is when you go 50 kilometers per hour, you need to stop. I mean, the car is going 50 kilometers per hour, which is huge, and suddenly, well, run out of runway, for example, or there's something coming up and you need to suddenly stop. If you rely on motors only, you're gonna put too much stress on the driveline. This is gonna break and fall apart if we task the driveline with braking the car. So what we're gonna do is we're gonna develop disc brakes. The discs are gonna be 3D printed. We're gonna, of course, link the files once it's done, so you can do your own. But we need disc brakes. That's also something that we need to develop. What we went through a few streams back with the disc brakes that I developed is cool, but the brakes that we gonna use here are gonna be slightly bigger diameter, and they need more power. So basically, we are gonna develop the whole system. The cylinders, I don't know, maybe we can use 2 small cylinders per wheel, but they're gonna be under pressure. So the system is gonna be a compressor with air tanks, and the actuation is gonna be via pneumatic switches instead of the pump. So it's gonna be like in a bus or a truck, basically pneumatic brakes. They're gonna have a lot more power. So this is also gonna be very interesting. Regarding this is for the Chiron project. And of course the bodywork and everything is gonna be as minimal as possible. We're gonna do basically a Formula One monocoque structure with the engines basically being a load-bearing part of everything, and just a triangle structure going to the rear. So it's gonna be as light as possible. And of course, we need to develop the 1 to 10 scale car that we are gonna use in the Buies Camp competition in September, hopefully. If by then we have the pandemic so far under control that that we can have gatherings again. So we need to develop a supercar of sorts. I don't know the rules yet, so Eurobricks needs to publish them, so I know what we can expect. So before I see the rules, I cannot judge. But yeah, this is the plan. Now, the way we could also go, and that's something that Eurobricks suggested, of course, is that we don't use a differential, neither in the front nor in the rear, but we would simply use these here. We would simply make it like that, and then longitudinally we would not have a differential at all, and left and rear the forces would be adjusted by the motors themselves, because Buies has apparently, I don't know yet, they have some software tweaks that can enable control of the motor separately, and at high speed you could basically steer the car just by providing more power to one side than to the other. I'm not a fan of this at all, to be honest. I like my central differential because it frees up the wheels to do whatever it's appropriate. So basically the car at speed, you have to understand that at low speeds it doesn't matter. At low speeds it's irrelevant what you have, but the higher the speeds, the more important this shit becomes. The suspension and driveline. So you want really the more kinetic energy the vehicle has, the less stress you want to put on the components. So you have to design them really to be as forgiving to everything. And the if we have a differential here in the front, we put a lot less strain on the entire driveline. And the, if we have a differential front, rear, and center, the car can do its own thing. Um, yeah, and I want the car to have mechanical grip, something which none of the other cars have, because you know uh, people rely on just wheels and basically tires and the power of motors. Uh, Nobody bothers with actual dynamics and suspension. And of course, the body needs to be torsionally really stiff. And that's really my goal. We'll see if it works, but we are gonna start with this. And as usual, of course, if we discover that it doesn't work, we can always change plans. That's the beauty of Lego. But I would like to explore the option with the central differential, a modified central differential, of course. Um, Simply because this is what interests me. I find this boring, and I think it's gonna be too stressful to the components in the car. Uh, well, the thing is that I don't think that the wheels are gonna slip. Um, I I really don't think that we are gonna have a lot of slippage, because there's you have to understand that there's a lot of torsion in the entire drivetrain. Regardless, whatever you do, there's torsion in the drivetrain. Even on this length, of course, as we use torsion for springs in the Charger, but you see, even on this length, we have this much torsion. I mean, we are gonna use for the drive lines, we're gonna use white connectors, of course, that are the stiffest possible. And I'm even thinking of, when we connect them, with uh, the two stud axles, that I would even glue them together, so that that the connection in the axles doesn't twist, so that really, if it twists, the plastic here is twisted through the entirety. Um, it's gonna be, I mean, that's the goal. It's gonna be the most extreme car made out of Lego that's possible. Um, and as I said, I understand that the most efficient uh, way would be if you skip all of the differentials and you just basically hook the engines directly to the axles, so you have two motors driving each axle directly without any drivetrain whatsoever. That would be the most efficient, technically. But it's, at the same time, as I explained, it's boring, and you have relatively heavy parts actually at the most extreme ends of the car, which I don't like either. I like my mass to be in the center of the car, if we're talking about the supercar. Um, well, congratulations, Alf. I would like to have one as well. Probably that's the goal for this year, to get an 880. Um, exactly, efficient but boring. And I think with our concept, So with the differentials and everything, we can get pretty close to what the others have, because you have to consider that our chassis, so our entire approach to building suspension and chassis, is going to be completely different to what the others are building. So I mean, Eurobricks has shown me a few of his concepts, and what I have in mind is going to be completely different to what he's doing, or the other people are doing. Uh, and you know, I like to be different, um, and being different doesn't mean that it's gonna be bad. It can be, you know, better. But if it is or it isn't, we're gonna see. Since last time I explained, you know, with the tires, that we are also going to make a test a test rig here. So we are gonna have rollers for all four wheels, and so that when I, for example, have the car here and I pull, you know, the camera back, we have the entire car here in front of us on rollers, and we can observe what the car is doing under power live. You know, so we can test everything. We can apply full power uh, and see what the drivetrain does. Does it bend a lot? Is there any cracking sounds indicating that gears are breaking? Um, all of that we can test it here, and you know, a lot of mistakes and a lot of errors, a lot of bad engineering is gonna be um, taken care of here. I don't want to have to re-engineer the car in the field. I've done that. I know how it is with the Mustang. You know, when I tested it with the engines, gears broke in the yard, so I had to come back to the desk, basically re-engineer stuff here, and then go back testing, and that's not fun. So if we're here, we can test most of the errors of our ways here directly on the test rig. It's basically, if you ever gone to a chip tuning garage, they basically have rollers where the car is rolling on them, so they can basically test the power and everything there on the spot. And that's what we're gonna do. That's gonna be interesting. And at the same time, we can see how the suspension reacts and all of that. That's gonna be, I think, very, very, very interesting to do. Yeah, these are my thoughts, basically. So obviously, the entire car, the Chiron, is gonna be our own creation. We are gonna use, of course, we're gonna use the colored parts from the Lego Chiron and a few design cues here and there, obviously. But we are gonna design the entire car from scratch, basically. The wheels are gonna be 3D printed, and basically the wheels are gonna be as big as this. We're not gonna use the same size as the Sierra, but rims as big as this, but they are gonna be 3D printed. And the tires are gonna be the tires from the creator Harley. Those tires are gonna fit on these wheels. So we're gonna have, as you can see here, we're gonna have a lot of room for disc brakes and suspension inside. So the discs can be bigger, and of course we are gonna use the LP Power wheel hubs, not with disc brakes like this, but the disc brakes themselves are gonna fit you see, into this groove. We're gonna make like a trilobe center intercut in the disc that's gonna basically fit on this, and then the wheel is gonna fit on this. So the wheel is basically gonna secure the disc. That's the idea. Well, interior wise, I don't know. I'm not a big fan of interiors. I'm not a big fan of interiors. Let's just rush through them and let others design them. Once I'm done with the interesting stuff. Uh, of course, I want to make the steering wheel inside of the car, and as if there's enough room for the driver. That's always the goal and challenge. Um, but most of the interior will be occupied by the batteries or the Buies battery packs. So and the GoPro mount. So the interior is gonna have a GoPro mount. So when we film all of this, we are gonna have a GoPro mounted inside of the car from a driver's point of view. So basically, we're gonna see footage of us driving the car. It's gonna be probably pretty intense. Friend of mine is a photographer, and he's gonna provide the equipment, and he found a GoPro with very good. It's not a GoPro; it's some camera with that's as small as the GoPro and has very good image stabilization. So when the car is driving, it's not gonna be just shaky cam footage, but we're gonna see really proper footage. Lego car going the equivalent of 400 kilometers. That's gonna be intense, I guess. So yeah, the wheels are gonna be like this. And since we are gonna use the LP Power wheel hubs, what I'm gonna do, since I want the rim to be really well seated on this, and these have slack, and I don't want the wheel to dislodge from them at any cost. I'm gonna use very small set screws to basically, in the first place, once we do the wheel hubs, when we glue this on, I'm gonna you see in each there is a, come on, what's he focusing now? Focus this. Yeah, you see those circles? Those circles are gonna be embossed. Basically, I'm gonna put screws in them. Screws in them that are gonna screw this part to this part. This is gonna happen for one reason only: safety. So at 50 kilometers per hour, I do not want these two parts to separate. So I'm gonna use the screws to basically fit those two together so that they don't separate at speed. Might not happen, but better safe than sorry. And then again here, I'm probably gonna use either screws, or I'm gonna, yeah, where is it? Here it is. Or I'm gonna drill them out and put a bar in it, or well, a bar, something that has a bar on the other side, just so that the wheel does not dislodge itself. I do have the files for the hex adapters for the Mustang, yeah. Yeah, I saw the Donut Media stuff, and that's basically what inspired me to do this. But their approach with the RC stuff is, I mean, it's wrong. It's uninteresting, wrong, and the RC chassis that they use is that they used is bad. Our chassis is gonna be worlds superior to that chassis. Um, the Ducati brake discs are completely useless to me because they have a central axle hole, and you know, with with this system, the axle hole is useless to us. What would we do with it? We're not gonna have an axle. Um, yeah, I'm gonna send them to you. Um, so yeah, these are my thoughts. This is the plan for the future. So Sierra is gonna be an RS 500. The Chiron is gonna have, at the start, we're gonna go with differentials. Um, we'll see later. It's gonna have 8 uh, Buick engines that are gonna be bolted to the monocoque and are basically gonna be part of the load bearing chassis of the car, like in a Formula One. So we want, because we want to minimize weight and maximize torsion. And of course, it's gonna have a gearbox, a 2-speed gearbox, two 2-speed gearboxes for each row of engines, um, to basically maximize the speed. 3D printed wheels, disc brakes, of course. Um, so we set the bar pretty high. And of course, the yet to be announced 1 to 10 supercar that we also have to make to compete in the September race for at the Buick camp. So these three goals are what awaits us in this year. We're gonna have a lot of work. Uh, I hope I can finish the charger instructions this week. So probably a week from now, we are gonna have charger instructions. Finally, uh, and yeah, I mean that's it for today. That's all I had to say. Uh, Tomorrow we're gonna start with the Sierra, of course. So I'm gonna find better blueprints for the hatchback version, and we can adjust all the dimensions and you know, continue with our work now that 4 doors is out of the question. And we'll see, you know, we'll see. Um, One last thing is, of course, at the beginning of the stream, I mentioned that I want to move to Twitch, and I would like to know your thoughts about it, since I think actually that on Twitch we're gonna get a bigger audience, and we are gonna have more options with the channel and all of that. And so I would like to, know your thoughts about it. I'm gonna put a poll together with an explanation on Facebook, and basically to get some feedback from you if you would like it or not. Yeah, of course you can post it on the Discord. That's why, I mean, the Discord is there for sharing. That's why we're all on Discord. If anybody is not on Discord yet, do join, so we can have live discussions whenever we feel like, you know. Usually I converse with friends on Telegram. Um, much I prefer Telegram because, you know, I have it on the phone. It's a standard app, and, you know. But, you know, Discord is fine. Whenever I'm at the computer, I can answer. We can talk, whatever. So yeah, that's the stream tonight. Thank you for watching. Do remember we have a Patreon. Since the Bugatti is gonna be expensive, even though we're not gonna build, we're not gonna buy the Lego Bugatti. That's off the table because we don't need it. We just need the panels, and that's it. Um, we're not gonna even we don't need any part of it except the outer panels. Um, but yeah, you know, Lego is expensive, and we have high goals for this year. So thanks for watching, and please do answer the poll on the Facebook page. I'm gonna link it into Discord as well, so you can see it. And perhaps we can move to Twitch by the next week. We'll see if you're on board. And with these words, I see you tomorrow.